All right, so let's jump into Android Studio here and look at some starter things with this. There was a couple of updates. It looks like I'm running the latest stable version. I'm probably just one iteration low on one of the SDKs or something. So even though I haven't done the update they just suggested, I'm pretty sure I'm running a very recent version. So anything you download, this should match up to either identically or extremely close. So I'm going to start a new Android Studio project. So it's going to look like this. We're going to call our application something. I'm going to go ahead and I'm going to leave the project location where it's saying here because I'm actually going to end up storing it on GitHub. Actually, I'm sorry, I've changed my mind about that. How many of you use Dropbox or something similar to Dropbox on your computers? Dropbox being this guy here. Let me go back here. Dropbox.com. Any of you use Dropbox.com? Okay. Strongly encourage you to keep using Dropbox.com. I would also strongly encourage you to store your code files in your Dropbox. So what I'm going to do is I'm actually going to choose the location for this project. To be in Dropbox. And let's go to CW. It's going to let me create a folder in here. All right, so we're going to store it in my Dropbox. I just picked a folder in there. And let's call this guy Android. Actually, just to plan ahead a little bit, I'm going to call this CSC537 Fall 2017 Homework 1. I'll be solving your first homework assignment in this project next class. So we'll just go a little bit ahead on that. Company domain, name it something like awesomefat.example.com is fine. So it's in like a domain format like that. Name it whatever you want. It doesn't matter. It only matters if you're ultimately going to put this up on the App Store, but you got to name it something. Go ahead and click next. Then it's asking you what version of the SDK are you writing for. All right, so now this is where things get a little interesting with Android. So recently they just came out with the latest version, Android 8, which is, I don't know, API level 30 or something like that. You know, whatever the math works out to. But one issue you'll run into is what's the difference between Android 8 and Android 7, do you think? All of you are iPhone users. What's the difference between iOS 11 and iOS 10? Most of you should be on iOS 11 now, right? Unless your phone was too old and you couldn't upgrade to it. I think you're too old, right? I think you're on. Okay. But if you were on iOS 10 before and you're on iOS 11 now, most things kind of the same. You notice some updates, some interface changes, things like that, but nothing major, right? You expect that pretty much everything that worked in iOS 10 still works in iOS 11, and then you maybe get some new stuff, right? And then maybe one or two things was removed or something. But in general, everything that used to be there that you used is still there, okay? Same thing's true with the Android evolution of their operating system. So what they're doing here is they're asking you, when you design your application, what is the minimum version of Android that you want to support? All right? Because if we assume that every new version is a superset of the previous version, that means anything that worked on iOS 10 will work on iOS 11. But things that work in iOS 11 won't necessarily work in iOS 10 if they take advantage of some new feature like ARKit or something like that, which is the augmented reality stuff for iOS 11. So what we're doing here is we're choosing what stuff do I want to have available to me for making this application such that I hit the largest audience? Now, if you are writing for iPhone, if you're writing something that's dealing with augmented reality, therefore you're using ARKit, you're going to have to use the iOS 11 SDK. You'll have to use the latest, greatest, whatever, and that's going to limit you to only people who are running that particular OS for who can use your software. Does that make sense? That's going to be all the new iPhone users, probably last year's iPhone users, and probably the year before that. So you're going to have the last 3 years worth of iPhone users, but outside of that, they might not be able to upgrade to iOS 11. So that's going to limit your audience, but the trade-off is you're taking advantage of something that's new, right? Well, most of the stuff we're going to do in here, isn't bleeding edge type stuff, right? It's, buttons and text boxes have worked for a while in Android. So what we answer here really doesn't matter. But when you're first starting a project, you're going to kind of pick what's the lowest common denominator, what's the lowest thing that you want to target. And one interesting thing you can do here, so I'm going to go ahead and I'm going to pick, here's Android 8. This is Oreo. This is the newest one, so it's API 26. Notice this only targets 1% of the devices. So that means if I target Android 8.0, only 1% of the devices that are out there will support it. So this is latest, greatest Samsung Galaxy phone, right? Should this support it? No, it does not have Oreo. So the upgrade process on Android is different. So this has Android 7, the latest version of 7. The only devices right now that have Oreo installed on them are the Pixel 2s, which that's Google's device. So they get the latest operating system immediately, and then your couple of flagship guys get them next. So next in line would be the guys like Samsung and stuff like that. Might be a month, might be 2 months, might be 5 months before I get Android 8. So the ecosystem on the Android side of things has always been called kind of fragmented. That's kind of evidence of that, where you're not necessarily dealing with the same OS across all these devices. Now, do you suspect that there's a humongous user experience difference between Android 7 and Android 8? Or would you suspect it's similar to iOS 10 to iOS 11? Probably in that ballpark, so not the end of the world. So what if we drop down to Android 7.1.1, which I think is what I'm running. This is still 1.5% of the devices. Android 7, 8% of the devices. Android 6, 40%. Android 5, 62%. Oh, that's for the wearable stuff. KitKat, you're at 90%. Jelly Bean, you don't jump up that much. You're at 96% there. So I think what they had picked was this ice cream sandwich, API 15, which hits 100%. What did Jelly Bean hit? That's 99.2%. So ice cream sandwich is on 100% of the devices that are on the App Store out there today. All right. So if the application you're writing doesn't take advantage of anything that was introduced after ice cream sandwich, you might as well support ice cream sandwich. If it doesn't take advantage of any of the new stuff since then. All right. So that's kind of the point. So lower API levels target more devices, but have fewer features available. All right. We are doing phone and tablet, but notice with the same tool, we can do the wearable stuff like watches. We could do Android TV, and then there's also Android for Auto. Their competitor with Apple CarKit. But we're doing phone and tablet. We'll do API 15. That'll work for all your homework assignments. No harm, no foul. Doesn't matter what you choose, really, because we're going to run it in the emulator. But if you want to put it, well, any of you have an Android tablet at home? All right, so for all of you, it literally makes no difference what you pick. because you're just going to run it in the emulator. All right. For me, I need to make sure I pick 7.1.1 or older. So I'm in the top 1.5% with what I have here, but I can't run. I'm not running Android 8.0 on this device, and I can't. I don't have the option to. I would have to root it and force it on there, but because the issue is when you have these other Android devices, so like this guy has a whole bunch of Samsung specific stuff on it. So you have normal Android, and then you have a whole bunch of bloatware. You know, like when you bought your HP laptop, it had a whole bunch of extra crap installed on it that you probably immediately uninstalled, right? Yeah, that's still on here. A couple of them are actually helpful, but you know, in general, you get a modified version of the operating system. It's still good. You know, Samsung's one of your popular ones, but it's you know, it's not pure Android. You'd have to get a Pixel to get Android as it was meant to be experienced, or something like that. All right, so I'll go ahead and hit next. And then I'll hit next again. And I like to choose empty activity. All right, so these are all kind of like starting point for interfaces. So you can do a basic activity, bottom navigation activity. So this would be like if you think about your iPhone applications that have some of those buttons on the very bottom to flip through things. If you want to do something with maps, login stuff, master detail flow, this is more for tablet type things, scrolling activity, whatever. I like to always start with empty. I don't want it to do too much stuff for me. Even when I'm doing iOS development, I like to start with a blank project. A single view application is what it is for iOS, and I like to build it myself. All right, so always choose empty, and that will give you a good starting point where it's a running app but doesn't do any fancy stuff. You have to kind of reverse engineer what they did. All right, and usually the first screen, they usually name main activity by default. If you want to change it, you can. I'm just going to leave it as main activity. First starting point, it's not going to hurt anything. And I'm going to have it generate a layout file. I will talk about this over the next, the next hour or so as we kind of talk about these. And then here's the layout name. So associated with this main activity, this is going to be our Java class file. We're going to have this layout file called activity main. And then they're saying, do you want it to be backwards compatible with this thing called app compat? Just say yes. Just keep it checked. That makes it compatible with some older versions of Android if it, if you happen to try to run it on an older device. So I'll go ahead and hit finish. It's going to do its thing. All right, I'll go ahead and close these little tip things. So screen should look like that. Up here in the upper left where it says project, if you click on that, it's going to open up this window, expand app, expand Java. The top thing has our main activity in it. Let me spread this out a little bit more. So notice that we have 3 different folders up here. One's just called homework, fall 2017 homework 1. They have Android test and we have test. So these other 2 are for something called unit testing, which we're not going to mess with, but that's what those are for if you want to have built-in tests. So as you get large projects in software development, you might want to have kind of a set of tests that you want to always apply to your Yeah. So let's say you have these 10 tests that your project needs to always be able to pass. You might set up those 10 unit tests so that in 6 months, when you add some feature to your application, you can still run it through those old unit tests to make sure you didn't break it for any old test it was supposed to pass. Because think about it, when you're writing code, kind of like at our level, we're writing something for like a homework assignment, we're kind of passively testing it as we're going through there, right? You're like, oh, does it work for this input? Does it work for this input? And that might be good enough situationally, but when you start thinking about a larger project that's working over a period of time, as you fix problems, you probably want to turn that problem into a unit test so that you make sure you don't unfix that problem in the future. Because we're always introducing new bugs into our code. When we add a feature, we also add a bug. So that's where unit tests come in. It's possible we might mess with one or something like that before the semester's over, but with 8 weeks, you're in a pretty compressed format here. So don't bet on it. It's kind of the punchline here. Okay. So anyways, we're going to be at this the top one here. That's not the test stuff. And here's our main activity. If you go ahead and double click on that, it's going to open up the code over here. Is that big enough? Can we see that? Is that a little small? Or can we see it? Okay. So anyways, this is our Java file for this first thing. You know what? I want to do something here. We can see that even better, right? All right, because I can definitely see it better. And that was really my motivation there. All right, so nice big font now. So this is going to be our the Java portion of our code here. And then the guy that marries up to this is inside of this folder down here called resources, res. And then in here we're going to have a layout folder. And we have our activity main. So I'll go ahead and double click on that and notice it just says hello world there in the middle of the screen. I'm going to go ahead and hit play here. Actually, I'm going to get rid of these guys because I don't think you'll see them by default. Oh, is there no way for me to get rid of it from in here? Well, it doesn't matter. I'm going to create a new virtual device, which is what you would do when you first launch it, because yours will show up as you have nothing here. So I'll create a new virtual device, and you can choose which device you want this thing to look like. For us, all that's really important is you pick a device that's running at least the latest version of the version of Android you're developing for. Okay. And you can pick a size that kind of makes sense for you. So notice that this is kind of the definition of these kind of pixelated or fragmented type of devices where we have 500 different phones that all have slightly different screen sizes, slightly different dots per inch, different resolutions, a lot of different things that play into it where your app might look slightly different on different devices. Where with iPhone, it's more fragmented than it used to be, but you still have, like 3 or 4 screen sizes, right? So things get a little bit interesting there. I'm going to go ahead, I'm going to choose the Pixel for really no good reason other than I've never chosen the Pixel before, so we're going to choose the Pixel. That's one of Google's devices. So I'll go ahead and hit next. And it's asking me what version of the OS do I want it to run, and it defaults to Marshmallow, which is Android 6. We were targeting Android 4.4 or whatever, so this is at least as new as that, so we're good. If you're targeting a newer version, you can certainly choose a newer version of the OS. You can even download Android 8 if you really wanted to. So I'm just going to leave Marshmallow as the default since we don't have to download anything new. I'll hit next. And then, if you want to change any of these automatic settings, you can. Otherwise, just hit finish. And this will create a new Android emulated device. So here's my Pixel. I'm going to use this little checkbox here that says use same selection for future launches. All right, so for this project, we're always going to launch on our Pixel device. So go ahead and hit OK. And it's going to launch the Android emulator. Now this is the thing that used to take a long time to launch. Look how pretty that is. It almost looks like an iPhone. It really does almost look like an iPhone, doesn't it? There are some really kind of seemingly stupid things I've run into on the Android device that I wasn't really expecting. Like, on an iPhone, when you're like on a web page that has a phone number on it and you want to call it, you just click it and it makes the call, right? The number has to be in a very specific format for that to work just like that for on Android. I would say most of the time so far I've had to like copy the phone number and then go and have to paste it into the phone app. Not the end of the world. I mean, I'm a fairly competent user, but I can imagine like that would be, if I start thinking about who are the phones for, that would be a problem for grandma, right? That's not a great user experience. So yeah, I would, all things being equal, I think iPhone is the better end user experience, but I've been pretty happy with this for a couple of things that I want to be able to do. For instance, some of the video streaming applications like DirecTV. I have the DirecTV app on here, and I don't have to worry about Apple's rules where that app isn't available for iOS. Normal DirecTV, they have a thing called DirecTV Now, where Apple gets 30% of the subscription fee. But if you're a DirecTV subscriber, on Android, you can get the DirecTV app and watch your DirecTV on demand and stuff from wherever you are. And that's not even available on iOS because of Apple's rules. Things like that have benefited me directly. But then the flip side is some other apps that I use pretty regularly. This is something we're going to run into here. For instance, there's an app called Sign Now I use for signing a lot of legal documents and things like that. And I had it on iPhone, I have it on here. And iPhone, I would say it worked flawlessly. Never had an issue with it. It's way clunkier on here. The PDF doesn't update as quickly. It's not as good, even though it's the same app from the same maker. And that's something I tell people when we're writing stuff for Android. Typically, for my business, if I'm writing an app for somebody, we write it for iPhone first and get it polished and working there, and then we port it to Android. And what you end up having then is you usually have the most polished experience on iPhone and then a close approximation on Android. It's not that Android is crappy. It's just because you're targeting so many different size devices, chances are when they wrote that app, it was probably designed for a much more normal size phone. And I'm trying to run it on this phone with this giant screen on it, and something about that interface just doesn't translate well. It's borderline unusable on here. And it was an app I relied on pretty heavily. So realistically, I'm going to have to find just a replacement application, something that was maybe written for a more recent Android version. But those are kind of your trade-offs, and I think it's stuff that would be expected. So even now, coming from an Android user's perspective, I'd still recommend iPhone for a majority of users. But we have both, so I can still use my wife's phone for testing, so I might as well have my DirecTV, I guess. Okay, so we saw the thing launch. There's our stupid Hello World program. So by choosing empty application, this is what they give you. They give you a working Hello World program. Okay, now I'm going to go ahead and I'm going to leave this emulator open. I'm just going to click back here. So I'm help improve Android Studio by sending information. That's fine. I already agreed. I have to agree again. All right. Okay, so we have two separate things here. Now let's go back to our notes here. And I know we talk about this. Actually, if you took, how many of you took 535 online? I know she did. You had it in person. You had it in person, or you have it online?
In person.
You had it in person with me?
Yeah.
Oh, I don't remember. You must not have been very memorable. Did I like you?
Because I used to sit there every class.
Oh, you sat by the video game guy.
Yeah.
Yeah. What happened to him?
I think he's taking another class.
I liked him. I liked him better than you. He's addicted to Grand Theft Auto, isn't he?
Yeah.
All right. So I don't remember. Did we talk about design patterns in the online class? All right. So let me talk about it again here, because that online class is a little bit dated. It's a little bit older version. So we had this concept called a design pattern, and I'll kind of not belabor this too much, but design patterns is a proposed good solution to a common problem. All right. Now, an issue here is what do I mean by good and what do I mean by common? All right. So academics love design patterns because it's a, you've heard this phrase before, publish or perish thing. So as an academic, we're supposed to publish stuff. Concordia is more of a teaching university. I'm a research professor here, so I have some research stuff I do that is more than the normal stuff. But in any case, it's less of a truth here. But generally speaking, academics who need to get publications love design patterns for computer science, because all we have to do is we could pick any problem that's out there that's common to somebody and propose a way to solve that problem. It doesn't have to be a great way to solve the problem, just a way. And we can argue why it's a good way. And then the worst that happens is somebody else writes a paper that says, well, we've reviewed that way, and here's an even better way, because that way wasn't actually very good. And that's okay, because research doesn't always mean advancing the field with something better. Research means advancing the field with more information. So sometimes your research can be, we tried this, sounded good on paper, didn't work. Thank you. Just letting you know so you don't waste your time doing the same thing we did. So, but in any case, so that's what a design pattern typically is. It's just this generalistic thing of a proposed good solution to a common problem. They also usually have cool names. Cool, quirky, you can replace that thing a couple different ways. Now, over the years, as you might imagine, some of these design patterns have become fairly famous. So even though there's zillions of them out there, and maybe most of them are kind of waste of times, they might even just be fake things just to get a quick publication. Maybe a lot of them are legitimate, but didn't necessarily rise to the top. But you could imagine over the years, certain ones have become, better, right? They've kind of survived the time-honored tests and have actually risen to the top as being, hey, these are pretty good things to stuff. One of them that we'll be using in here, I'm actually not going to introduce it yet. I'll just introduce the concept of design patterns right now, because when we first do it in here, we'll talk about it. But one of these that I'll talk about right now is called the MVC. Does anybody remember MVC from the previous class? What does that guy stand for? Or you just remember its existence? This is the model view controller. What's your excuse? You're young. I remembered it. I'm old. I forgot my name last week. All right, so model view controller. Like I said, a lot of these guys have crazy names. What this guy says is this. It's a good idea to separate your logic from your interface and your data. Now, for us right now, we're not worrying about the data. That's kind of more of a database type thing. But in this little discussion we're going to have right now, we're really focused on the first part of this. It's a good idea to keep our logic in one place and our interface in another place. What does our program look like when it's running? How does our program actually work while it's running? Make sense? That's MVC. Now, what's important here to know is that MVC is not an implementation. Okay? So MVC does not dictate that something must be implemented a certain way. What MVC says that somebody who wants to support this design pattern should have an implementation that makes it easy for the programmer to have their logic in one place and their interface in another place. It's a concept. That's it. It's a concept. And as we're experiencing it here, Android lets us experience this concept by having our code in one place. Here's our main activity. That's our logic is in one file. And our interface is in a different file. Okay? So our interface is in this file called activity main XML. This is where we design our interface, and we'll come back to this in a few minutes. Here's our logic. It's in this file called mainActivity.java, but now we have to have some way of connecting these guys back together. So we want to be able to work on them separate, but they still need to know about each other, right? So that last part of MVC be a way for the various components to communicate with each other. All right? So we're saying, look, it makes a lot of sense for us to separate them. Sometimes I want to work on my interface. I want to make my application look better. Sometimes I want to work on my logic. I want to make my application work better. Okay? But there's crossover, right? Because when I add something over here and I need to talk to it over here, we need to somehow be able to connect those guys. So the second we separate them to make our lives easier a lot of the time, now we've created a new problem, right? The problem of having these guys talk. All right? So that's the thing that makes the unique implementation. For iOS, this is done through something called IB outlets and IB actions. In Android, it's a little bit more direct. So here in main activity, notice this guy extends something called an app compat activity. But what's the most important for us here is this thing called an activity. And let me just create a slide for that right now. We'll come back and talk about it here in a second. Okay, but we have a function here that was created for us. It's called OnCreate. So one thing we run into in mobile applications, whether it's iOS or Android, is we have something called the activity lifecycle. Okay, that is different points in time. Let's write it in here. Different points in time where we can communicate with the app, with the activity as things are happening. Okay, there's some built-in points in time. We'll talk more about them here in a little bit, but just understand that there's a life cycle. There are different moments during the time that an activity is alive that we can interject things. Okay. And the one that's put in front of us right off the bat here is OnCreate. When this activity is first born, when it's first created, this guy gets called one time, OnCreate. We get to do some stuff. All right. So inside of here, what are we doing? We're calling the OnCreate function of our parent. That's what super is. Super is how an object refers to its parent. So his parent is something of type app compat activity. Who cares? Doesn't matter. This line will always be there. At some point, we'll talk about it in more detail, but not important. It's just there. So if I'm a child of app compat activity, the very first thing I'll do is I'm going to take this bundle of crap that this OnCreate gave me, and I'll toss it to my parent and say, hey, Mom, do what you can to set me up, and then I'll take it from there. All right, so that's what we're doing here. We're passing the buck to our parent to let them do any sort of instantiation stuff out of our hands. We don't care. We didn't write it. This is the important part here. I like to put this dot in front of this guy. So now I'm telling main activity to set his content view equal to r.layout.activity main. So this R class this is an automatically generated class in Android that keeps all of our application resources like layouts. And let's just say stuff, because there are things beyond layouts. All right, so we'll just say stuff. So notice under our resource folder, we have a folder called layout. r.layout.activity_main. So this guy gets generated for us. We didn't have to connect those dots. By us creating this XML file over here, this guy right here, Android did the magic of generating this class called R that has a bunch of static stuff in it that allows us to reference our layouts. All right. So here inside of my main activity, I'm saying I want my interface associated with this class. Logic, interface. I want this logic to be associated with this interface. So I'm going to set this logic's content view, because this guy is an activity. So his content view, that is what you can see, so the mask he wears. So his content view is going to be our activity main layout. That's how we're connecting those two to each other. Make sense? Okay. So this is where we design it. This is where it shows up in here. Just to kind of take that one step further, just to show you something beyond this, if I come to this label right here, so this guy's a text view is the actual kind of animal he is. So it's a text view. We're going to go ahead and give this guy an ID. So we're going to call this guy my label. That's going to be like the variable name associated with that guy. So I created something called my label. By default, he didn't have an ID because we didn't need to have access to him. He existed, but we didn't programmatically need to contact him. But now I want to be able to set that label. Okay? So I went ahead and gave him a name called my label. And by doing that, now back here, and I can go ahead and get that text view. So I'm going to say text view TV is equal to this dot find view by ID r dot ID dot my label. So that guy got created for me. By me naming that thing my label, that R class updated to give me an ID for something called my label. That's how I connected those two. Okay, it's not happy with me right now because this guy actually comes out of here as the generic view. I'm trying to store it inside of a text view. So I need to cast this guy to be a text view. So now he's happy. And then I'll say tv.setText equal to LOL. Okay, so on create, I'll go ahead and grab the text view associated with this interface and then change the text from the default that's hello world to say LOL. Go ahead and run this again. Here's my LOL. Make sense? So that's MVC in action. So as you see, MVC in Android is very explicit. Not a whole lot of magic tricks going on there outside of that one thing where Android keeps that class called r.java up to date for us. That's just something we're promised. That r.java will always have your stuff in it. And Android does that for us. That way we have a way inside of our logic to talk about things in our interface. No, code, you got to code it in Android. There's a drag drop in iOS. Yeah. But at the end of the day, it's the same thing. In fact, I might even mention that once you get going, this is actually more productive. The drag drop seems nice, but sometimes just typing it is faster. See what I'm saying? You know, it's like a, you know, it's probably like most things Apple. There's a lot of things about Apple that just seems like, oh, that's really an elegant design or something like that. I mean, Xcode is really put together nicely where, you know, over here in the code, you would create an IB outlet for your TextView, and then you'd go over here to your interface. You'd see the outlet over here. You drag it to this label, connecting it up, and it's like, you know, you feel like you physically connected those guys, right? But it really is slower to do it, to do it that way. It takes more time. So just kind of a thing. All right, so understand how MVC is kind of put together in Android. Okay, not the end of the world. Guys connect up without too much trouble. So we just learn. Oh, there's all sorts of kinds of views. Yeah, everything in. I mean, this is true across the board. In fact, let's actually go in here now and have this discussion about activities. So what's an activity? An activity is a screen in our application. And this actually becomes a little bit of a difference between how iOS applications and Android applications are actually put together. So in iOS, we have an application that is a collection of view controllers. And these view controllers, so a view controller is to iOS as an activity is to Android. They're the same kind of animals. They're synonymous with each other. All right. But in iOS, a program is self-contained, where your program has a collection of view controllers that make up that program. Android works a little differently. So Android creates a virtual machine for every one of your applications. Forget about the virtual machine thing for a second, because that's more of a Java, Android operating system way of doing things. So at the end of the day, if we kind of disconnect that virtual machine, don't think about that, our applications are actually a collection of activities where each activity is kind of an application in and of itself. You know, and we see that because built into Android, we have a built-in back button. So right here, I can hit this back button here, and it's going to take me back. So when you think about the Android operating system, what is it doing? It's showing an activity on top of an activity on top of an activity. Now, you might have 3 or 4 activities that are all part of the same application, but they are actually separate activities. So they are separate processes. See, we didn't waste our time. Okay, they're separate processes running in the operating system. So there's some stuff to that. Where in the iOS, there's not a built-in back button. So iOS, if an app is going to have a back button, it has to provide a back button, right? You can get back to the home screen by pressing your home button, but the back button in Android takes you to the previous activity, whatever that was. Make sense? They actually, in newer versions of Android, have compartmentalized this a little bit more. That's why I bring back that virtual machine in, where an app now is closer to an iOS app in that it is self-contained. It's self-contained inside of its own virtual machine. And what's nice about that is before with Android, you used to have to manage the stack of activities. So let's say you opened up your Bank of America app. Then you opened up 2 more apps, went back to Bank of America, and then opened up a screen in Bank of America. If you would hit back, you would go to the previous one of your other apps. You would have to hit back twice to get to Bank of America again, because you have this like stack of activities, where now activities belong to a virtual machine. So when you switch contexts back into Bank of America, you're dealing with the activity stack of Bank of America at that point. So if you hit back, you go to the previous screen that you last were at inside of Bank of America. And if this is the first screen, it goes out to the home screen. It closes the app. That makes it functionally perform more like iOS apps perform. Right? iOS apps are self-contained. So, I mean, if you're inside of an iOS app, even though there isn't a built-in back button in iOS, if you're in an app and there's a back button in there, that back button functions for that app, right? It goes to the previous screen of that app. It doesn't take you back to YouTube. Yeah. But that's still just like a back button. That's just a gesture-based navigation instead of, it's still not, that's not built into the OS. Yeah, the OS has swipe-based gestures, but not related to an app. So like if you're on an iPhone and you're inside the Bank of America app and you swipe from the top of the screen down, that'll bring up your notifications, right? So that's the operating system responding to your stuff, not doing stuff directed to Bank of America, specifically. All right, but punchline for us here is you find out pretty quick that if you compare iOS to Android for mobile application development, they have far, far, far more in common than they have differences. There's tiny little trade-offs like, oh, well, this guy does it this way, this guy does it this way. Like you were mentioning, well, isn't the drag and drop thing nicer? Yeah, it seems nicer for the first 5 minutes, and then you find out it's actually slower. So, it's who's to say which is better? They both are accomplishing the same problem, or the same solution. What is that? It's a solution to MVC. So they have different approaches to MVC, but at the end of the day, how do I get my interface to talk to my code? Make sense? So our activities, every screen in our Android application is an activity. Every screen in our iPhone application is a view controller. Okay, if you want to just keep tabs. They're the same, okay? Now, what is an activity, though? Similarly, the same answer here would be, what is a view controller? An activity is a collection of views, okay? So what's a view? Anything you could see. Text views are views. Edit texts are views. If you can see it on the screen, it's a view. So we have this generic idea of a view in Android. In iOS development, it's a generic idea of a UI view. Very similar. Okay. You have this generic idea of a view, and that generic idea is this is something that lives on the screen somewhere. Okay. Now, different views play by different rules, right? So, for instance, a label and a text box, they're both things you can see, and they both have some commonalities, like they live at a certain place on our screen, but they do function differently, right? A label is just kind of information delivering, where a text box is something you can click on and change. It's more interactive or something like that. So we can kind of think about those types of things as it comes to views, and think about the apps you've used on your phones. You can kind of get a pretty quick list of some of the different kinds of views that exist. You have scroll views where you can swipe stuff and see things flying through the screen, that kind of stuff, right? And we'll mess with some of those different kind of the widgets, if you will. But you recognize that once you know how to work with one, you start seeing the same patterns working with anything that's kind of like that one. Same thing's true on iPhone. We'll do a table view. So, anytime you have on Android, it's called a list view, but, if you have a list of stuff on iPhone where you can kind of scroll through it, when you learn how to make that list view work, or that table view on iPhone, when you learn how to program that, it's not overly difficult, but there's a little bit of a cadence to it. Once you learn how to do that, then you pretty much learn how to do anything like that for all these other widgets that are kind of similar to that. So collection views, where for instance, your photo library, right? It's just a whole bunch of pictures and kind of a grid. Well, how do you program something like that? Well, it's got a whole lot in common with a table view. Just your cells, instead of being rows, are little squares. All right, so they have a lot in common. Same thing's true over on Android. Android, we use these things called adapters to make it work. On iPhone, they're called delegates and data sources. Same thing. All right, so at the generic level here, our activities are collections of views. That means our activity is a thing. It's a program running on the Android device. Yet the things that we see on the screen are the collection of views kind of laid inside of each other.
So activities are the generic feature, and then the views the specific function?
This feels like it makes worse sense than what I said.
Or could you just rephrase yours?
The activity is like the car. The views are like the seats and the leather and the stuff that's inside the car. That's the stuff you actually experience, right? You could have 5 cars that are right next to each other, and they're all cars. They all drive. They all have a commonality to them. But you get inside of each of those cars, and they might have a different interface, right? This guy has this kind of steering wheel, and it has 8 seats, and these other things that are in there. It's it's got cloth seats versus leather seats, that kind of stuff. The seats and those things are like our views. That's what you see once you're in the car or using the car. Okay, so a view is anything you can see. So generally speaking, what are we doing when we're connecting the dots? At least early on for us, when we're connecting our logic to our interfaces themselves, what are we actually doing? We are gluing. Well, we are giving ourselves programmatic access to a view. All right. So if I come back over to the code here, what did I do right here? I have a type of view called a text view, and I asked an activity. So this guy, even though he's this app compat activity, he's an activity. He's an extra compatible activity. All right, he's an activity. So I'm asking this activity to hunt within himself for one of his views, because I've advertised that an activity is a collection of views, right? So I've asked him to hunt within himself for one of his views. Which view? The view whose ID is my label. And that's the one that I created right here. I named it my label. So find view by ID is going to return the generic view. I then said I happen to know that dude is a text view. So I'm going to go ahead and I'm going to typecast him to be a text view. So now I'll store him inside of a variable of type text view. And text views happen to allow me to set their text. And I'll set the text to LOL. And I'm doing all this on create. Okay? Now, might it make sense for that not to happen on create? Maybe we want that to happen when we click a button or something like that. That might make some sense. So I'm going to name something here. We're going to call this public void on when the app opens, when this activity becomes live for the very first time, OnCreate gets called for that activity. So let's call this on change me button pressed. So I'm creating a method here. It's yelling at me because it wants me to import the thing for view. So if I, what is it? Alt enter? Yeah. So I did that. If I come up here to my imports, it imported android.view.view. Gave me access to that library. All right, so this is a plain Jane function. Now this function has to be public, it has to be void, and it has to take a single view as a parameter. Now you can name it whatever you want in here. So this is the function that I intend. So now we're seeing kind of another feature of MVC. This is a function that I intend to get called when I click some button on my interface. All right, and by the way I've named this, I'm probably going to have the button called change me. Make sense? And what do I want to happen in here? I want this guy to go ahead and grab the text view and set its text. So I don't want it to happen right off the bat. I want it to happen as a response to me hitting a button on my app. Make sense? So my app should pop up initially showing hello world. Then I click the button, which we haven't even created yet, but I click the button and then it becomes LOL. Make sense? That's what I want to happen. So I'm going to create this function, and I intend on this function getting called as a result of clicking a button on my screen. I haven't made that happen yet. That's my intent. Now my setup to make sure, so I'm kind of playing the MVC game with Android at this point. So I had to make this guy a public void function, and I had to make sure he takes in a view v as a parameter. Actually, the v is not important, but it has to be a view that he takes in as a parameter. You can name it Q or LOL or whatever you want to name the variable. The name of the function here is unimportant other than I need to remember it because I'm going to need it when I go to connect the interface to call this guy. Okay, so we'll pause this part here for a second. Come back into my interface here. Now, one thing we're going to need notice here, we have this thing called a constraint layout. Actually, is this going to be okay? I don't know if I want to get too much into that right now, if this is actually going to work okay. So I'm going to try to grab a button here, and I'm going to drag it out here. All right, so I'll put that button underneath my hello world. All right, historically, we'll see how far we go because the constraint layout last time I used this was pretty new. We'll see if it's improved some. Historically, when I'm doing Android programming, what I actually do is I use linear layouts, horizontal and vertical linear layouts for putting stuff into my code. So for example, if I put a horizontal linear layout in here, and let me just, okay, I'll put that guy up there. So this invisible box plays by the rules of a horizontal linear layout. So that means anything I throw in there, it'll line up horizontally. So if I keep throwing, if I go to my my widgets, I put a button in there, then I put another button in there, I put another button in there, see how it's lining them up horizontally. And then if I want to, I could put a vertical linear layout in here to have multiple rows. So historically, I have built my Android interfaces that way, using vertical and linear, vertical and horizontal linear layouts to basically squeeze stuff into different corners. Now, iPhone has always used this kind of a constraint-based layout, where when you're designing your interface, you just put stuff exactly where you want them. That works pretty well for iPhone, given the fact that they, for a long time, had a very consistent screen layout, right? Things were in the same place. Well, things are less true today for that. So they have this thing with iOS development called Autolayout, which is akin to this constraint layout thing that says, we'll do our best to make it look the way it's going to look on these different devices. So we'll have to see how well it works on here. Not the end of the world for us because we're not going to be creating these beautiful interfaces. Interface design ends up becoming a kind of a skill set in and of itself. Okay, just like my wife drags me out to these paint night things where we go to places that usually serve wine and we paint things. You've seen some of my artwork, right? Yeah. Oh, I have it hung in my office.
Yeah, I see your drawing.
That was the Android logo. It was a very good Android logo.
Ours was still better though, because you guys were side by side.
Well, right. Plus, she followed the rules because, like, there's like an art instructor that's up front that says this is what we're painting today. Show you what the final thing should look like, and then they tell you, okay, first we're going to do this one, and I go off script immediately. You know, I'm hitting the wine hard, right? And I'm just painting whatever I want. My wife wants to follow them, so yeah. I mean, hers looks like what the artist was trying to make us look like. I don't remember. Not Android. Yeah, it was probably like some, you know, like fall leaf, or maybe there was one that we did that was like a moon with elephants staring up at it, like it was like a African safari type thing. I made the moon look like a giant Pac-Man, and then I had the ghost. So I'm a very talented artist, is what I'm saying. In any case, you'll learn your own skills at designing your interfaces. Generally speaking, most programmers are, this is kind of an unfair statement. Programmers like me are mostly programmers, not really designers. You do have kind of a hybrid skill set when you get into this idea of like a web developer. A lot of web developers have kind of a hybrid skill set where they might be actually pretty good designers as well as pretty good programmers. In fact, a lot of them are actually designers who started dabbling in programming and became competent programmers. I'm good enough at design to like slap stuff together, but if I'm writing a piece of software that I'm going to release, I require a professional designer to make my interfaces. And then they give me the pieces, and I can glue them on here in the way they've told me they want it to look. But I'm slapping together a functional interface because my skill set is in programming, not in design. All right, so keep your expectations in check, I suppose. But in any case, one nice thing you can run into here, just kind of showing you the tool. So I can click around on stuff in here and grab individual pieces and do stuff with them. And this actually, over the years, has begun working significantly better. I can't even tell you how bad this interface builder used to be in Android. I mean, it was unusable for a long, long time. So over the years, you end up, I mean, for instance, you have this button out here called text. That doesn't exist on the iPhone version of this. You have to go out of your way to actually edit the text of this stuff. Because underneath the hood here, we have these things called data representation languages. And we've heard of these before. So, for instance, XML and JSON are two examples of data representation languages. They are a way of formatting our data in such a way that, you know, we can give meaning to what the data is. All right. So the people who made these interface builders for either Apple or for the Android side of things, even though we're dragging and dropping buttons and linear layouts and all this crap out here, under the hood, this is being represented as an XML document. Here's our text view called my label. You know, this is the representation of that label. We just drug it out on the screen and then double-clicked on it and said, hello world. Named it my label. This is how it's actually represented under the hood using a data representation language. Now we can come in here and we can manipulate it ourselves right here. So instead of having it say hello world, we can just change this to say boo. Go back to design, and now it says boo. Make sense? Because this guy is interpreting our data representation language into a visual representation of it. So Android gives us the ability to go in here and modify this. Now, somebody who's extremely pro-Android might say, well, that's something that's nice for us developers, and you know, we like to sometimes get into the code and stuff. And that might be relatively fair to say today. Okay. I promise you, you needed this tab for doing Android interfaces before, because this whole drag and drop thing, that did not work. If you wanted your interface to do anything other than accidental drag and drop, you had to go in here and modify it in here. Okay? So, in any case, it allows you to do that if you need to get to it. But a nicer thing for us in here is, you know, let's say I want to get rid of this whole linear layout thing I threw in here, just as the example. I can click it right here. Well, let me just delete it directly from there. Yep, just click it and hit delete. And it'll delete that and all the children underneath it. Okay? So sometimes that's an easier way of grabbing elements of your interface. You can get it over here in the component tree rather than up here. Oh yeah, yeah, this text always is the current version of what we see in here, up here. Because what we're looking at right here and the text is the same. In fact, what we're looking at here is the result of the text. When we deleted it from here, what happened is the text updated and then this screen refreshed. Because this screen is the interpretation of that text. So the text is actually what was modified. Okay? All right, so in any case, what we ultimately want to happen is we want that function to get called whenever we click this button. So I'm going to go ahead and I'm going to double click on this button and we're going to change the text that's on the button. And we're going to have that, I'm just going to have it say change me. I don't remember what we said the other thing was. Okay. Now, notice that these are kind of like the let's call it the important properties, the properties that are commonly used here. There is a way to get to additional properties. So we can do view all properties. So there's a whole lot more stuff available in here. But let's say that this is our go-to stuff. Okay. Now I'm going to give you a word of warning here. I'm not sure how well it's going to work here, but I'm about to connect that function we previously wrote to the on-click action of this button. Historically, this has been a buggy aspect of Android Studio. Okay? It's always fixable, but you sometimes have to actually connect it up 2 or 3 times. It's very strange. So we're going to try it, see what happens. So I expect when I hit this drop-down button here, that's interesting. I'll click on the button. on change me button press. So it's finding that function I wrote in there. We're not out of the woods yet. This pretty much always works. It always finds it. So I'll select that. It gives you the list of functions that you have provided that followed that naming structure. And that naming structure was that it had to be public void and take a single view as a parameter. So these two things and that piece. That's what kind of set it up as being a potential on-click function. All right, because all on-click functions, the view they take in is the view that called this function. Because nothing says that I couldn't have 10 buttons, 10 different buttons on my interface that all call this same function. And I might be interested in which button called me. That make sense? I might want to know, was the view that called me button 1 or was the view that called me button 2? So I can look at the ID of the view to find out which button was the guy that called. Because buttons are things that we see, therefore they must be views. Right? So this is the most generic thing. So for this button, I chose his on-click to be this on change me ideally flippy. So that means when I click this button, it should call back to this on change me button pressed, passing himself in as the view that got called. I'm not using that variable, but if we happen to be interested in who called this function, we could find out. What am I going to do in here? I'm going to go ahead and ask this activity to go ahead and grab the label, and then we'll set the label to LOL. That makes sense? What's happening here? So again, this is MVC, except this time, instead of giving ourselves access to a widget through a variable, now we're having an action, an event. When we click that button, his on-click event fires. That then is, we've connected it back to this function call for it to get called. Go ahead and hit play. All right, yeah, actually right off the bat, you see that change me is actually in a weird place relative to the other thing. So I'll go ahead and click that and notice it says LOL. Now, if you run into a problem, we haven't seen it yet, this worked the first time through, but if you do run into a problem where that button is not actually working, what I've always done is I've gone in here, I've just highlighted the name of this function. None of the other stuff, just the name. I click on change me. I go to on click and I just paste that name in there. That usually works. Historically, there's been a bugginess associated with the connecting the dots there. So don't just immediately give up if your on click is not working. But this also says that be suspicious of that on click thing, or maybe test it to make sure it's connected correctly first before you go and write a whole bunch of logic behind the scenes. That way you don't think one thing's broken and start working on your logic when it was actually never actually calling your function. Okay?
You called the button, the view, which is the button, you called it V. How do we connect that to?
So this guy's ID, here, I'll show you actually. Oh, this guy popped back up here. So change me goes to LOL. So instead of just setting it to LOL, why don't we set it to the empty string? We'll go ahead and grab his ID. And then I'm going to concatenate onto that just so you can see it. This button, his ID is called button, but that guy's going to have a name. So if I come back in here, so I'm going to concatenate onto this guy, a space, a colon, a space. I'll concatenate onto that r.id.button. The ID associated with the view that called this guy is going to be a number. So I'm going to concatenate that number onto this. r.id.button is also going to be a number. They should be the same number. Since I know that that button, the button I clicked on is the guy who called this. So he's going to pass himself in as V. So I'm asking it to set the text in the label to whatever the ID of V is. I happen to know that we only have one button. So I'm also going to go ahead and put in button's ID. We should see the same number twice, proving that it was that same guy. Okay? So big number, same number. So that's the unique identifier for that button. Make sense? Now, if I want to see the difference though, I can do this. I can come in here and I'll go ahead and put a different button out here. All right, and this guy's ID was button 5, just randomly gave it an ID. And I'll go ahead and make this guy's on click call that same function. So now the dude who calls the function is actually a different ID than button. So now it should show in the label the ID of this guy followed by the ID of this guy, since I hard-coded r.id.button, not r.id.button5. In my code here, I'm assuming it's always button that's calling me. Yet, there's actually two different possibilities for who might call this function. Button or button5 could call this guy. So we're going to see that under those circumstances, it'll actually be a different ID. So there's the same. There's a slight difference. 142. Oh, that's the same actually. Yeah, that's a different one. So that one ends in a 4. This one ends in a 3. Yeah, so you're seeing how these constraint things, and this really has most to do with that. I'm just not skilled at using the constraint-based layout. So what I would usually do here to make my interface, just to show you an easier way of making interfaces, I would do this. So I'm going to take my, I'm going to go to layouts. Now I'm going to create a vertical linear layout. All right, I'm going to go ahead and I'm going to drag my label into that. If it doesn't let you do it in there, you can go ahead and take your label and drag it into the linear layout in here. Then I'll put my buttons in there as well. And I'll put my label up top in that list. I'll take my linear layout here. I'll just fill the screen with it. Oop. Oh, actually, right now it's set, I'll show you what it's doing here. It's set to wrap content. So the width, I'm going to have it match parent. That'll squeeze all out to whatever the size of the parent is, which in this case is the screen. The height, I'll also have match parent. Okay, and now my buttons are full width buttons and things like that, so I can change that if I want. So the layout width of my button I have is match parent. If I want, I can change it to just 100. That'll squeeze it down. I can do change me. I can also have this guy as 100. Let's actually make him a little wider. So we'll make him 130 so we can fit the text on there. We'll make him 130 just to match that. All right, and then here's my label. Now, realistically, we probably want our label, the text, to be centered, right? So the way we accomplish that in Android is through gravity. So every view has gravity associated with it. Now, think about this. If this room, so we're in a view, we all live in a view right now. if the gravity on this room was set so that we were all sucked to the ceiling, if we set the room's gravity to, let's call it up, all of us would immediately suck to the ceiling, right? Because we are contained within this room. So if I take this label and I go to view all properties on it, because the gravity is not one of the choices here, and I go down to gravity, and I change it to, there's a couple of different things here. There's center, so center vertical, center horizontal, or just center, which center will be vertical and horizontal. So if I click that, see how the guy sucked to the middle? That boo sucked into the middle of that thing, because that text lived inside of that room, lived inside of that text view. And when I set the gravity to center, everything sucked to the middle of the room. Okay, but it did not have an effect out here. Now, if I click on my linear layout and I set his gravity to center, now anything that lives within that linear layout will suck to the center, but the contents of my label are not impacted by that. My label itself is impacted, but he's already stretched all the way from side to side, so he's not going to move. Okay, well, actually, he will move. Because if I say center, that's going to center it vertically and horizontally. So if I click on this guy here, they move to the center of the screen. But if I only want it to be centered horizontally, I can click on, is this the vertical or is this the horizontal? That's the horizontal. Now that sets the gravity for this container to be centered horizontally, which means that each of these elements are sucked to the center of that screen. Yet, I can now say my label, I can set his gravity, instead of center, I can make it right, for example. So there's a different gravitational environment inside of the label than there is outside of the label. So these three elements here, they are affected by the gravity of their container, which is linear layout. The text inside of my label is affected by the gravity of my label. Does that make sense how gravity works? They would, yeah. So if I have this button, I want his text, I can turn gravity on for that button. And let's say I made it right. Yeah. So kind of makes sense? All right, so that's how you, so typically when I'm making interfaces, I make linear interfaces like this because I feel like I have a lot more control over it. But nothing keeps you from putting interfaces. So for instance, let's say I wanted these buttons right next to each other. Well, what I can do is inside this linear layout, I can put a horizontal layout after my label there. And then I can put my two buttons You got this. I can put my two buttons inside there. And my label's above it. So now I have a linear layout, a vertical linear layout that has two components in it. A label and a horizontal linear layout. My horizontal linear layout has two components in it, two buttons that are put those buttons right next to each other. Now, what you might do then, though, is you might say that you want your horizontal linear layout instead of having, I'm going to view fewer properties just to go back to this main thing. Instead of having its height be match parent, which makes it fill this entire screen, I'm going to actually have its height be wrap content, which will only be the height of those two buttons that are in there. Make sense? So these are kind of those tools you end up playing around with. I feel like you have a lot more control over the interface doing this, even though I'm certain that it's true that the constraint layout probably gives you more flexibility. I'm just not skilled at using it. All right, so now you'll see that the things on our screen will look the way they look here. Well, there's the change me. I'll go ahead and center this guy again. I'll set the gravity to him for him to be center. Gravity. Must be in a different subsection of this. Ah, here it is. There we go. So now it's centered on there. And we'll look good. So, make sense? All right, so let's take about a 6-minute break. Come back, we'll do our last hour, and we'll go from there.